అంటే ఇప్పుడు
Yeah, Abhi, tell me, Abhi.
యాక్సలరేషన్ యాక్సలరేషన్ ఫార్ములా
Acceleration formula.
v into dv by dx.
Okay, okay. So actually, I don't know anything. Yeah, okay. I'll ask you one question, Abhi. Actually, I don't know anything, Abhi. So then I ask you, like, what is meant by work energy theorem? So what did you say work energy theorem? I don't know, Abhi. I don't know any formula or anything.
Some
Just tell me what did you have to be understood work energy theorem?
work equals to kinetic energy
Excellent, excellent,
or
Abhi. Excellent,
change
Abhi.
in kinetic.
Yeah, excellent, Abhi. So that is the sufficient answer for the work energy theorem. So total work done in a body, it is equal to change in kinetic energy. So that is states the kinetic energy theorem. Clear? So that will derive it up away. Yesterday class that will derive it. So means I'll selected in path. I'll selected in path like this, Abhi. So this is the path, Abhi. So this is the path. So in this path, for example, this is the path having a length as x, but I'll take as a small length that is in tx. So in this dx, so how much of work is done? So from like particle is moving from in this distance from here to here. So what is the work? How much of work is done? We are calculating. That work is it is equal to that work it is equal to what I'm getting, Abhi?
Works delta k.
Yeah, delta K means kinetic energy. That work it is equal to kinetic energy. I'll prove it away. Some mathematical equations I can apply and I'll get the derivation. That is in work equal to change in kinetic energy. Finally, I'm getting. So this is thing is states the kinetic energy theorem. So what are the examples of kinetic energy theorem? Okay? What is a work energy theorem? Sorry,
So
examples.
rest to motions అంటే
Rest
a
to
బాడీ
motion.
ఒక బాడీ ఉంది అది రెస్ట్ లో ఉంది. సో
Okay,
ఫోర్స్ అప్లై
okay,
అది మోషన్ వస్తుంది.
okay. That motion is a kinetic energy. So that kinetic energy it is equal to work. That kinetic energy it is equal to work. So for example, that is in like as a due to which force is acting on that. So like for example, car you can take as a car. So car is accelerating. So car is accelerating from rest to some point. Car is accelerating from rest. So that engine experienced a force. That force is that due to that force work is experienced. That work is called as a kinetic energy of work. So that is the example. Second example is if you can push the body. So if you can push from like 10 kg of mass from your study room to kitchen. So here also some work is done. That work is kinetic energy of work. So that work is also called kinetic energy of work due to motion. So these are the examples we'll discuss, Abhi. Okay, Abhi. Next, I will give you some problem, Abhi. So we will discuss some problem, Abhi. Yesterday class. So what is the problem we'll discuss, Abhi? Yesterday, tell me.
ఎస్ అప్లికేషన్ టైప్
Yeah, application type problem we'll discuss. Tell me
బ్లాక్
what
ఆఫ్
did you
మాస్
have to? Yeah, block of
ఎస్
mass M. Block
with
of
with
mass M
initial with initial
with
speed v naught
with
towards
initial.
the stationary spring.
Yeah,
అంటే
okay,
నార్మల్ స్ప్రింగ్ ఉంది సార్ వాల్
okay,
అటాచ్.
excellent.
సో మాస్ ఆఫ్ ఏ బాడీ స్ప్రింగ్ కి పుష్ అయింది సార్, అంటే పుష్ చేసింది.
Okay, very good. Okay,
సో ఆ స్ప్రింగ్ అనేది ఇంకొంచెం దగ్గరగా వస్తుంది అంటే
Compression. It is compressed from actual position to somewhere. Actual position to somewhere.
సో
Okay, very good.
ఫైనల్ వెలాసిటీ జీరో వస్తుంది.
Yeah, final velocity zero. Excellent, Abhi. Then what we are calculating, Abhi, this problem?
Calculating x
X means
x డిస్టెన్స్ అంటే స్ప్రింగ్ ఎంత కంప్రెస్.
excellent, Abhi. So spring is how much it is compressed, Abhi. So spring is how much it is compressed, we'll discuss. So spring how much it is compressed, we'll discuss. Okay, very good, Abhi. So this is the application type of problem, Abhi. So what is the x value we are getting, Abhi?
అండర్ రూట్ ఎంవి నాట్ స్క్వేర్ బై కే.
Okay, very good, Abhi, very good. So now today also we'll discuss some more application type problem, Abhi. So second problem, write down second problem, Abhi. This is very, very important concept, Abhi. Now today we'll discuss on. Write down problem, Abhi. A particle is a particle is a particle is slides along a particle is slides along a track. A particle is slides along a track along a track along a track shown in figure shown in figure shown in figure shown in figure. The flat part has length. The flat part has length. The flat part has length. The flat part has length L equal L equal to 3 meters. 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 The curved portion are the curved portion are the curved portion are frictionless. The curved portion are frictionless. The curved portion are frictionless. For the flat part, for the flat part, for the flat part, mu equal to 0.2, mu equal to 0.2, mu equal to 0.2, mu equal to 0.2. The particle is released. The particle is released. The particle is released at a point. The particle is released at a point. The particle is released at a point A. The particle is released at a point A. The particle is released at a point A, which is at a height, which is at a height h is equal, which is at a height h is equal, which is at a height h is equal to 1.5 meters. 1.5 meters. Where does the where does the where does the particle finally comes to rest? Particle finally comes to rest. Particle finally comes to rest. So draw the diagram of it. Draw the figure. Draw the figure. Draw the figure of it. Draw the figure. Draw the figure. Draw the figure. This is height h. This is height h is equal to 1.5 meters. And this is the length is given. Flat length, that is 3 meters. This is L. L equal to 3 meters. L equal to 3 meters. Here friction coefficient is mu equal to 0.2. Mu equal to 0.2. This is point A. This is point A. This is point B. This is point C. This is point C. Sorry. This is point C. This is point D. And exactly off. This is point E. Yeah, this is the problem is given, Abhi. This is the problem is given. So this is also one type of application type problem, Abhi.
Yeah, application.
Yeah, application type problem, Abhi. Just read this problem, Abhi. So
Yeah,
what we are
clear.
calculating? Yeah, tell me, Abhi. What we are
Plan the
calculating in this
problem.
problem? Yeah. So where you are doing this problem, Abhi?
First time, sir.
Yeah, okay, okay, no problem, Abhi. So this is very, very important concept, Abhi. So here we are doing some problem solving techniques also. We have to learn before doing this problem, Abhi. Yeah, so actually what we are calculating in this problem, Abhi, identify it, Abhi, what we are calculating in this problem.
Yes, sir. Where does the particle comes to rest?
Yeah, so where it starts, Abhi, particle, where it starts?
A, sir. A point.
Yeah, from A. So this is the point A, particle is start, Abhi. So if we can fall down like this, Abhi, so where it is stop? So where it is stop? It is stops from DR, it is stops from CR, it is stops from ER, it is stops from BR. So now we are calculating, Abhi. So for this given data, now we are calculating. So before going to this problem, okay, so before going to solve this problem, so we have some one problem solving technique is there, Abhi. So that we have to learn before going to solve this problem solving technique, PST. So problem solving techniques means intended to apply work energy theorem, to apply work energy theorem, to apply work energy theorem, apply work energy theorem, work energy theorem, to apply work energy theorem. So for example, Abhi, so for example, ideally, in a body, so in a body, how many types of works are existing in the body, Abhi? How many types of works are existing in the body?
Uh, two types. Two types.
Only two types. Yeah, only two types of works are existed for the body.
No, sir. Three types. Three types.
Tell me, Abhi, what are they?
First over, night over, zero over.
No, 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 no. Okay, Abhi, I will give you a hint, Abhi. So, so for example, like we are so here body is there, Abhi. So here B to C it is moving, Abhi. So B to C particle is moving. So which type of forces are acting, Abhi? So how what is the type of work is done, Abhi? B
Uh,
to C. This is
it
the
is
flat surface or
constant.
frictionless, Abhi. It is a flat surface or friction. It is having a friction or
Flat
not, Abhi?
surface. No, sir.
Yeah, it is. Yeah, it is having a friction or not, Abhi, in this surface.
No, sir.
No, here it is given a friction coefficient. Yeah, okay, no problem, Abhi. No problem. I'll explain, Abhi. So here friction. So due to friction, friction force. Due to friction force, here some work is done. So that work is frictional work. So frictional work. Due to frictional force, wala work is experienced. That work is frictional force. So commonly, so gravitation. Due to gravity, wala some work is done. So that is gravitational work. Due to friction, so work is done. And if you can take spring, so spring force. Due to spring force, work is done. Due to spring force is also work is done. And due to some external force, due to some external force also work is done. This is equal to this is equal to change in kinetic energy, Avi. This is equal to change in kinetic energy.
And
So all these works are experienced or not, Abhi. So sometimes some works are experienced. So depends on the application. Depends on the application. Some works are experienced. Some works are does not experience, Abhi. But commonly these works are existed in really. For an ideal case, these works are experienced. For example, Abhi. So here this is the this is the like here spring is there, Abhi. Here spring is there. Now spring is elongation or spring is compressed, Abhi. So for example, spring is elongation or compressed. So if you can apply like this force, Abhi, in this direction you can apply the force. So here due to this spring force, due to this spring force, your spring is compressed from here to here. Here to here spring is compressed. Here work is done, Abhi. Here work is done or not, Abhi?
it's done.
Here work is done. So due to spring force, work is done. That work is spring work. That is the work is spring work. So are commonly so like for example, so this is the like surface, earth surface. So here some body is there, Abhi. Some body is there, like 10 mass of m. So you can lift like this, Abhi. You can lifting and somewhere you are putting, Abhi. Somewhere you are putting this body. So it is force is experienced or not, Abhi. So it is work is done or not, Abhi, due to this work, due to this force.
Yes, sir.
Yeah, here
Yes.
that force is against the gravitational force. That force is against the gravitational force. Due to gravity is also work is done. Due to gravity is also work is done. Or due to spring force is also work is done. Due to friction also work is done, Abhi. Due to friction also work is done. For example, this is the body. So you can apply like this direction. You can apply like this direction force. You are applying like this direction force. So this surface is having a friction. That friction, for example, mu. So due to this friction coefficient, due to this friction coefficient, your body is working towards backside. Your body is working towards backside. Due to this friction force, your body is working backside towards the backside. So due to friction force is also work is experienced. That work is friction force of work. So due to external force, you can apply the external force also, work is done. So commonly work energy theorem states that work experienced on the body, it is equal to change in kinetic energy, Abhi. So you remember these problems all in technique, Abhi. It is easy to do the problem, Abhi. Any problem, it is easy to do this, Abhi. Copy this, Abhi. Problems all in technique. Now we are doing this problem, Abhi, after. So identify, here writing, Abhi. To apply work energy theorem, to apply work energy theorem, identify all the forces, identify all the forces, identify all the forces due to which the work, due to which the work, due to which the work is done, due to which the work is done, due to which the work is done, due to which the work is done. So you can write like this expression, okay? Due to gravitational force of work is, and due to frictional force, this is the work. Due to spring, this is the work. Due to external force, this is the work. That is equal to change in kinetic energy.
Okay, sir.
Yeah, okay, Abhi. So by using this technique, Abhi, by using this technique, so in this given problem, how many types of forces and works experienced, Abhi? How many types of forces are experienced and work? Due to that forces, how many types of work is done, Abhi? How many types of works are done, Abhi, in this problem? Yeah, in this problem, how many types of works experienced, Abhi?
Four, sir.
Yeah, okay. Forces are forces. Due to that forces, work is experienced, Abhi. So that's why I'm asking, how many types of works are done, Abhi, in this problem? Tell me.
Work, sir. Okay.
Yeah, works. How many types of works are done? From the particle is moving from A to somewhere.
A to B one work, B to C another one.
Yeah, A to B is one work done. So which work is done, Abhi? Due to that work only, body's particle is moving from A to B only. So this is what type of work, Abhi?
Um,
Yeah, tell me.
external works.
Wait, there you cannot apply external force away. This is the flat surface. It is you can particle is placed here. It is automatically fall down. Automatically fall down or which type of forces are experienced? Due to that forces, work is done away
Gravity,
from A to B. Do you know
gravitation.
gravitational force? Yeah, due to that gravitational force, work is done. That is gravitational work. WG plus plus
Constant work.
constant work is not there. Abhi. Constant work is not there.
Frictional
From
force.
yeah,
Frictional.
and due to frictional
Okay,
coefficient,
frictional.
frictional force is also there. So that is due to that frictional force, frictional work is done. That is WF. Yeah. Here any remaining forces are experienced. The spring force is there, Abhi here.
No, sir.
Yeah, spring force is also not there, and external force is also not there. Just you can fall down, Abhi, like this. It is equal to 2. In this problem, it is equal to 2. Change in change in
Change in kinetic energy.
kinetic energy. So you can first initially you can identify the how many types of works are done for the given problem. That is important, Abhi. How many types of works are done given problem is important. So then it is easy to do the problem, Abhi. So change in kinetic energy means kinetic energy at final minus
Mhm.
kinetic energy
minus
kinetic
initial.
kinetic energy final minus kinetic energy initial. Here, Abhi. Here Abhi. So what is the gravitational force? So due to gravitational force, how much of work is done? What is the formula? Wg equal to
mg.
mgh mgh.
Okay.
Already we are derived, Abhi. So at the earlier classes we are derived mgh.
Until lifting body mgh, sir.
Yeah, you can lifting is also due to gravity, Abhi. You can like for example, so this is the mass m. You can lift it, Abhi, like for certain height. You are placed in certain height. This is the h. Certain height you can place this body. So here also due to gravity force your work is done. That work is also W equal to mgh. You are placed so somewhere like a certain height. Your body is located on certain height. It is also fall down like this also. Same work is done. Same work is done. That work is mgh only. Due to gravity only. Due to gravity only. But sign convention is important. Here sign convention is minus mgh. Here sign convention is plus gh. because of here gravity is positive.
Okay.
Okay, Navi.
అంటే పాజిటివ్.
Yeah, gravity is positive. Your bodies fall down కదా towards the gravity. Particle ఎక్కడ ఉంది? Where it is particle located?
అప్పుడు
Yeah, upward. Body is fall, particle is fall down from A to B కదా. Due to in gravity direction or opposite direction?
గ్రావిటేషన్.
Yeah, due to gravity direction. So, due to gravity direction. So that's why your G is positive. Your acceleration is positive plus G కదా.
ఎస్ అంటే బాడీ లిఫ్ట్ అయితే మైనస్.
Yeah, body lift అయితే your acceleration is against from the gravity అవి. Your acceleration is against from the gravity. So that's why your acceleration will become
మైనస్.
minus Z. Your acceleration will become minus Z.
అప్పుడు
Here your
మైనస్
accel
ఎంజీహెచ్.
yeah minus mgh. Clear? Given problem, your particle is fall down from A to B, not for B to A. So if a particle is fall down from B to A, so you can lifting from B to A, your acceleration will become minus Z that time only. Clear?
ఓకే సార్.
Yeah. Then frictional force. So frictional force is always in opposite side. Frictional force is always in opposite direction. It it works experienced in backward direction, not for the force direction. So that's why you can take frictional force in minus. Okay, Nabi.
ఓకే సార్.
Yeah. So here frictional force that is F into frictional force that is like for example that friction is K Fk. So into displacement that is in X. That is in X. That is in X. Now here Abhi, here it is very important Abhi. Here very important Abhi. So this is the final kinetic velocity. So I'll write Abhi. This is I'm writing like this Abhi. This is final and this is initial. I'm writing like this. Half m into v final square minus v initial square Abhi. Yeah. What is the initial speed of the particle here? What is the initial speed Abhi?
ఇనిషియల్ స్పీడ్.
Look this diagram. It is not given. Just you tell me what is the given. We know we have to study in motion and laws
ఇనిషియల్.
of motion. Bodies fall down from certain height. Here, what is the initial velocity?
యూ ప్లస్ ఏటీ.
Ah, no. Not for calculating. Tell me what is the answer here only. Abhi, body is located certain height. Abhi, here body is located. Your bodies fall down some certain height to here. Abhi, what is the initial velocity here?
ఎస్. జీరో
Tell
జీరో.
me. Zero. Your initial velocity is
జీరో.
zero. Your initial velocity is zero. Next, Abhi. So, what is the final velocity, Abhi?
ప్లస్ ప్లస్
Yeah,
ప్లస్ టూ.
you can. Yeah, you can read your last sentence of your problem, Abhi. You can read it, Abhi. So, what is the last sentence of the problem?
So where does the particle finally comes to rest?
Yeah, for finally particle comes to rest or not, Abhi. It is accelerating, so
Yes.
it is accelerating. Finally, it will become resting. So, means your initial velocity is zero, and your final velocity is also zero. So, what is the value of change in kinetic energy? This is
K initial minus K minus
0 minus 0, 0. 0 into everything is,
0.
yeah, this term is 0.
Yes.
This is mgh, this is mgh, this is minus fk into x, fk into x. Now what is
FK
the
means
Fk? It is a friction force abhi. Friction force. Kinetic
K
friction force abhi. K means kinetic friction force abhi. Not for the static friction force. Kinetic friction force. Body is in moving abhi. So that's why I'm writing kinetic friction force. Okay now.
goes
Yeah, this is the minus Fkx right side. It is moving on RHS side. It will become a positive Fk into x. Fk into x. Now I'm writing Abhi here. Listen Abhi. So Fk friction force. What is the formula? Friction force.
friction force minus
Already I'm writing minus Abhi. What is the formula? Friction force formula into what is the formula? Mu into mu into
mu mg.
mu mg. So means directly. I don't write directly. So mu into n. So n it is a normal force that is in mg. You can write like this also, no problem. So this is mu into mg. Your n is normal force that is in mg. Mu into mg. Excellent. Mu into mg into x. So here which terms are cancelled away from this problem? Which terms are cancelled?
mg
Mg is cancelled.
mg
Mg and mg is cancelled. Now here, Abhi, x equal to, now here x equal to, what is the value? X equal to
h by mu
h by
h by mu
h, h by mu,
mu
h by mu. So what is the given Abhi? H is how much is given in this problem?
1.5 meters. Right.
1.5 meters. What is the mu is given? How much is given?
0.2.
0.2.
If by 2,
What is the value? So point is cancelled. And 2 7 ja.
15 by 2,
Yeah, 15 by 2. That
7.5.
is in 7.5 meters. So where your particle is stop, Abhi?
After 7.5 meters.
Yeah, at 7.5 your particle is stop. So here 7.5 is where it is there, Abhi, in this given problem. So this is very, very important, Abhi. Just look this diagram. So your particle is releasing from A. Your particle is releasing from A. So where it is stop, Abhi? I'll get a distance x equal to 7.5. After some calculation, I'll get x equal to 7.5. So in this problem, Abhi, where your particle is stop, I'll get 7.5 meters. Tell me. This is very, very important, Abhi.
F plus 3 point, it is
Excellent, Abhi. Excellent answer, Abhi. How you said E?
1.5 plus 3 plus
Yeah,
minus 8%.
yeah, 1.5 plus 3. Tell me, 1.5 plus 3?
4.5.
Yeah,
Again, two
okay.
so two
Y-
backwards.
Yeah, again it is backwards because of your bodies does not moving from D to C because it is accelerating again. It is accelerating in backside again. So initially your body is initially it is starts and it starts and it is moving. So it is up to it is C. So it is move up to C. So this is the height. Your particle is does not lift the height a bit. So it is traveling in backside again. Again, this is 1.5. This is 3. This is again
2 meters.
the yeah. So again, yeah, okay, okay.
Backwards again.
Yeah, backwards only. So it is moving from 1.5. Initially it is covered 1.5 from B. Then it is moving on B to C. So it is 3 meters. It is 3 meters. This is 1.5. Now 4.5. Now 4.5. Then again it moves. Then again it is moves. Again it moves from 1.5. Again it is moves from 1.5. Yeah, okay. Uh, yeah, okay, Abhi. Your body is moving from A to B. That is 1.5. Yeah, okay. Yeah. 1.5. It is moving away. Ila. It is moving up to here. Then it is C to D. C to D. So this is 1.5. This is 1.53. So 3 plus 3 is 6. Then it is backwards. Then it is backwards.
Half 1.5.
Then it is backwards up to 1.5. So here actually it is stops from E. లేదంటే ఇలా కూడా రాయొచ్చు. You can locate like this also, no problem. So it is your answer is 7.5 only. 7.5. It is equal to 2. It is equal to 2. 3 plus 3 plus 3 plus 1.5.
Plus 1.5.
1.5. So 3 plus 3. 3 plus 3 means it is 3 plus 3 means it is B to B to D. B to C.
Wait.
B to C. This is B to C.
A
This
to
is
B.
C to B.
A to B plus D to C plus
Hmm.
half B to C or half B to C.
Yeah, okay.
Half B to C.
Okay, okay, Abhi. No problem. C to B. Okay, Abhi. Your body is moving from A to B. ఇక్కడ నుంచి ఇక్కడికి వచ్చేసింది. How much distance it is covered? 1.5. Then body is moving from B to C. This is 3. 3 plus 1.5. This is 4.5. Then 4.5 తర్వాత again back side వచ్చేసింది. 4 plus 4.5 plus 1.5. 6.5.
4.5 plus 1.5. 6.
6. లేదంటే A to B. B to C. మళ్ళీ again C to B. 3 plus 3 6. Then B to E. Yeah, okay, Abhi. So given problem ఏంటంటే given problem is what they want calculating, Abhi.
So where the particle